Let's look at another example of simple linear regression. In this example, we want to calculate how long it takes people to get here with traffic from how long it takes them to get here without traffic. So we've got data for people, the commute that it takes them to get to class with no traffic, and then data on how long it takes them to get here with traffic. And the way that we're going to do this is we're going to use simple linear regression. We're going to try to get an equation where y, the commute with traffic, is a function of the commute with no traffic in the form of the equation y equals some number times x plus a constant. So let's do this by, since there's only two variables, we can use it. We can use a scatter plot to make the linear regression. So I go to Insert, I go to Charts, I choose the scatter plot, the dots up here. I choose the first one, and that gives me the dots with the X. The first column is the commute no traffic on the bottom. The Y-axis is the commute time. And let's add some axis titles. So chart axis titles, we need primary horizontal. So this is commute time with no traffic. And let's go and add a axis title primary vertical, and this will be commute time with traffic. We'll always want to label the axes so we can tell what's going on. Now, we also want to add a trend line. So we go to Add Chart Element, and we go to Trend Line. And I'm just going to choose more trend line options because we want to get the equation and the r squared in there also. We will move over here. We want a linear equation, and we want to display the equation on the chart, and we want to display r squared value on the chart also. And here we have our equation, y equals 0.8379x plus 18.489. Now, when we report that, we'd want to round that to 2 decimal points because that's too many decimal points to be comfortable looking at. And then r squared equals 0.4172, about 42%. So what that basically means is that we can see a strong trend that for almost all places, the commute time with no traffic is a function of the distance. However, we've got some outliers here that really mess things up. And those happen to be people that are coming from Pasadena to Azusa during rush hour, and that 210 freeway is an absolute disaster. So even though it's a short distance, and normally it only takes 15 or 20 minutes, it can take up to 2 hours. So these outliers are actually pulling this line up, especially for the lower values. If we didn't have these outliers, the regression coefficient would be even stronger, because most other people don't have to deal with the traffic too much, but it's mainly people coming from Pasadena eastbound on the 210. So this is how we do linear regression with making a scatter plot when we have just one predictor variable, the commute time with no traffic, in order to predict what we're interested in, the commute time with traffic.